Okay, welcome back to Study Business and Statistics Academy. And we've been doing this kind of like a calculus series for a long period of time. Today is another lesson. And we're going to go through another lesson, means like another question. We can look into another question that's going to be very heavily utilized in practical application. Plus that that's going to be very helpful even for the like when if you're taking differential equation classes. This is going to be that kind of like a foundation for you to move on to the differential equation classes. Okay, in Calc 2 or Calc 1, Calc 2, Calc 3, that in these three classes, calculus with analytic geometry, depend on that different school have like a different contents of the material to be covered under those Calc 1, 2, 3, or maybe they have 4, 5, or like a whole bunch of series. It doesn't matter in any situation, in any school, whatever the method, that whatever the format they might have, doesn't matter. But let's look at that, how to solve like an initial value problem that's going to be found in some kind of that test or quizzes in that your calculus class. Okay, sometimes this kind of a question you have already encountered several times. Okay, let's look at this one and then try to let's see how to solve this one. Okay, this is my question with the fancy Q. I hope that you can see very clearly. Yeah, good. So Q, solve the initial value problem dy over dt equals t plus, t minus 9 y 9. See, it's been given like that. This part is the important part. This is called the initial value. Initial value. That means what? Here you can easily say y is a function of t. Y is a function of t. See? Y is a function of t. See? Y is a function of t. Y is a function I can write like this, say for the down the road as abbreviation function of t. See? It's a function of t. Y is a function of t. Therefore, this initial value means initial value or initial condition. Sometimes we call the condition. Initial condition. Okay. Initial okay, look like it. Okay. Initial condition. Initial condition. Okay. Means when t equals 9 and t equals 9, y is 4. That's what it means. In the beginning, at the beginning, when the time was 9, y may be anything, t may be anything. No, in this case, let's say per time, when t equals 9, when t equals 9 seconds, what would be the distance that particular particle has traveled, particular object has traveled, or something like that. Okay? That's the initial value. It's being given. Based on that one, they want to ask us to solve. Solve means what? Solve means find y in terms of t. Find y. It's not y here. The derivative has been given. When the derivative given, how to go back to the initial y. Solve means find y. Find y in terms of t. Or simply find y. Because yt. That's the idea. Okay. Let's see how to get this done. Okay. Let's see how to get this done. It's easy. Initial value problem means initial condition has been given. Okay. So sometimes they call this one is a differential equation. Differential equation. Okay. They call this one differential equation. See? Differential. First order. See? Here one. So this one, see? This is a first order differential I can write with this abbreviation down the road, differential equation. See? Equation, for the equation I can write this abbreviation down the road. See? It's a first order differential equation. And this is a kind of we are laying down foundation for you to move on to the differential equation classes down the road. This is like a first and foremost thing you're going to do in that in the very beginning. That's why we have encountered this kind of a question in this calculus series. For this is already derivative has been given, and then we have to go back to the original function, underlying function. It's called the underlying function or original function. How to go back? It has already been differentiated. Then you have to do integrate. That's it. Integration would be the technique you have to utilize. In order to get this done, what are you going to do? Since this is 1 and 1, you can use the variable separable method. Separate dy and dt. See, two operators. This is an operator. This is an operator too. These both coming together, you're going to call this one operator. See, come together, just one operator. But the same operator can be split into two parts as a two operators. See, dy over dt. See, but when it comes to this derivative, we don't call that one two operators, just one operator. See, y has been differentiated with respect to t. The operator would be this one. See? Here, you can easily think about this one as two operators now, dy dt. And bring dt to the right hand side. To the right hand side. Right hand side, RHS, where all t terms are. See, since already that we have all the t terms on the right hand side, you're going to take to the right hand side. By any chance that if you have all the t terms or the operator in the denominator in the left hand side, you're going to take that one to the left hand side. Okay, there's no fixed method. Okay, it's everything based on the way that how it's been given. Okay. Okay, then let's see. Okay, so then let's go. Let's do what this thing. Separate dy over dt and dy. See, I separated. Then t plus 2 e to the power of t minus 9 already you have here, and dt. See, that's all I did. It's very easy. It's a piece of cake. You don't have to be stressful about anything. There's no any heavy mechanism over here. Simply I separated all the two operators and brought one to the other side, the denominator. Whatever appears on the denominator, I brought to the other side. That's it. Then integrate both sides. Then integrate both sides. Okay. Integrate both sides with respect to their operators. Okay. With respect to their operators. With respect to their operators sides with respect to, look at with respect to respect to. We can abbreviate this one like a WRT down the road. You don't have to write the whole thing. With respect to their respective operators. Operator. See? That means simply you're going to operate this side by, with respect to this operator, this side by that operator. See? dy t plus 2e t minus 9 dt whole thing integrate. See, that's the integral. This is we don't see the limits. You see, infinite integrals. If you want, you can do it like this, and then later on we see how to find c. Okay, I'm gonna get this done in two ways. Okay, method 1 and method 2. Okay, I'm gonna integrate this one and write the final answer in two ways. Okay, method 1. Method 1. Integrate both sides and evaluating side and evaluating c. C means what? The constant of integration. The constant of integration. Okay, you can evaluate integration. Then you can write the final answer. Okay, let's see how this should be done. Okay, so you can remember when you integrate this one, dy become y. See, very easy, it's gone. An equal sign. T become what? T to the second divided by 2, because we have a 1, you're going to add another 1. See, another 1. See? And you divide by the same thing, very easy. Plus 2 times, you go over here, same thing. See? This derivative, then you take the derivative of this whole thing. Whole thing derivative should be multiplied by the whole thing derivative. Derivative of this guy is 1, derivative of 9 is 0. That's it. See? Piece of cake. Plus c. That's c. That's it, the constant of integration. We're done. Then a little bit rearrange. Y half t squared. See, same thing you can write like this way. Instead of writing t squared over 2, you can just simply say half. Okay? Plus, this one 2 times is 2. So t minus 9 plus c. See, plus c. This is not the function yet. You see, we got y. Now you're going to use the initial condition. Now, with the aid of the initial condition, we get what we get. We know when t equals 9, y equals 4. We know that. Okay. We know that. Okay. Yet we know that when t equals 9, y equals 4. Let's plug in this into that. That's it. Substitute this into, if you want, you can call this one star. See? Star. So substitute these values. Substitute these values into star. Okay, then let's see what we're gonna get. See, they say y equals 9. Y equals 9. No, y is that right? No, y equals 4. Sorry, y equals 4. Y equals 4. T is 9 squared plus 2e 9 minus 9 plus c. You see? So just simplify this one and find c. That's it. See? 4 1/2 9 times 9 81. See, this one is 0. See, e to the 0 plus c plus c. See, e to the 0 means the whole thing is 1. See, 1. Therefore, you have half 81 over 2 plus 2 plus c. See? Then let's simplify. Let's bring everything to this side. 4 minus 1 over 2 minus 2 is c. See, 4 minus 2 is 2. 2 minus 81 over 2 is c. See? Then from this one, you can say 2 times 2, 4. 4 minus 81 over 2 plus c. C equals how much? Negative 77. Therefore, c is negative 77 over 2. Let's see. Then you're going to plug in that c into the original liquid, our stuff. Then substitute this c into again stuff. This c equals negative 77 over into star. That's all. That's the final answer. See, very easy. You can remember you had y half t squared half t squared 2 e t minus like this. Your star was like this. Remember? No? Yeah. So then you're going to plug in c. Y half t squared plus 2e t minus 9 minus 77 over 2. See? That's it. Very easy. So just the process. But you have to just work on it. Okay, you cannot be lazy. You have to get the answer, the final answer. Otherwise, you don't see the clear function. Okay, it's t squared. So you get half t squared. That's the original function. This is nothing but y is a function of t. See, if you want, you can write like that too. What's the method 2 to get the c? When you come to this stage, can you remember? I'm talking about the method 2. In method 2, Okay. Method 2. What we have method 2? Method 2, then we have this one, dy over dt, have, not have, okay? I'm going to go to the original function, okay? T plus 2et minus 9, no? That's the original one. Then we separated, can you remember? We separated t plus 2et minus 9 dt. We were there. Then what are you going to do? You integrate. Okay, I'm going to dy integrate t plus 2et minus 9 dt. So the way that I'm going right now, you don't have to worry about c, okay? Because this is the way that I'm saying. This is now the finite integral, infinite integral. So I'm going to convert this to a finite integral by doing what? By putting the initial condition. Look at what I'm doing. When this is, look at it, t equals 9, y equals 4. See? Can you remember initial condition? When t equals 9, y equals 4, I'm going to plug in those bounds. Then t equals t, that means t, okay? T equals t, y equals y. That's the general point. This is the initial point, initial value. This is a general value. General value is the value expressed in terms of y and t. General value for y, initial value for y, initial value for t. See, initial value is a general value. General value. See, it's a general value for t. I'm talking about t. Okay, I'm talking about the upper bound. I'm talking about the upper bound. I'm talking about the upper bound. General value. Okay. That means, in another way, this means integral 4 to y dy t integral 9 to t, see, t plus 2e t minus this one. See, that's what I meant. Okay. So, okay, this one. I converted this to a finite integral by including all the upper bounds and lower bounds for the t as well as for y. Okay. So when you integrate this side, you get y, then you have to put the lower bound and upper bound. Then here you have to integrate, then you get t squared over 2 plus 2e t minus 9 times 1 minus 0. You can remember. You get to put the same thing for the exponent, but you have to take the derivative of the exponent. See, t is 1 and constant becomes this one, but the lower bound 9, here t. See? Then we will rearrange this one. Y goes from 4 to y. This one half t squared plus 2e t minus 9. Gonna go from 9 to t. See, 9 to t. Then let's plug in upper bound and lower bound. Okay, let's plug in upper bound and lower bound. Okay, that's what I'm gonna do. I'm gonna go ahead and upper bound means y replaced by y, then minus 4. And this side, upper bound means t half t squared plus 2e t minus 9, that's for the upper bound, minus for the lower bound, you get 9 half 9 squared. I'm going to put the bracket plus 2e 9 minus 9. You see, you don't see c anymore because you don't need the c because the upper bounds and lower bounds are plugging into this integral. Okay. Then let's simplify. Y minus 4 equals half t squared plus 2et minus 9 plus 81 over 2 plus this one 0. Can you remember this 0? E to the 0 is how much? Right to this side. E to the 0 is whole thing is 1. So plus 2. See? Then I can isolate y on this side by taking the 4 to the other side. This one minus, sorry. Minus, because of that minus. Okay. So half t squared plus 2e t minus 9 minus 81 over 2 minus 2 plus 4. Plus 4. Let's simplify a little bit. That's it. Y is half t squared 2e t minus 9 minus 81 over 2 minus 2 plus 2 plus 2 minus 2 plus 4. See, we didn't put C. We didn't evaluate C. I just set up upper bound and lower bound. F t squared plus 2e t minus 9 and 2 minus 77 plus 4. I'm sorry, minus 81 plus 4. So y have t squared plus 2e t minus 9 minus 77 over 2. Y is nothing but y is a function of t. Very easy. Okay, thank you very much, guys, that we can see you guys again in another question like this in another video. Okay, see you guys pretty soon. Thank you very much. Have a good day. Take care and stay safe and be well. Okay, take care. Thank you. Bye-bye. Bye-bye.